Hello, everyone. My name is Sam. I own a small startup here in Silicon Valley called Pixeom, and I'm here to talk to you a little bit about our experience combining different open source technologies together to create a product for our customers who are primarily factories that have industrial IoT applications. Quick background about me, I'm a former engineer from Microsoft. I worked on Hyper-V, Windows Server, a bunch of different OS level types of projects. We started the company about 3 years ago, raised $4 million from Samsung and Flextronics, and now we're up to 63 employees. Actually, they're called Flex now, not Flextronics. Real quick background on what we ended up doing was evolving the paradigm in terms of how people are building IoT applications. So if you look at how people were building them 3 years ago, everyone was building on a public cloud. They were deploying some service up in a data center and then letting all of the different things and sensors, connected devices on premise send their data indiscriminatorily up to the cloud. As I'm sure everyone here is aware, devices are becoming smarter. They're generating more data much more quickly. Smart cars, self-driving cars, 10 gigabytes of data per mile. Cameras, these VR cameras are generating hundreds of gigabytes of data per second. Now, a lot of people out there are deploying edge data centers geographically dispersed to address this, deploying hubs in the home, much smarter hubs that can take care of some of this processing locally. But I'm here to tell you guys today that that's not enough based on our experience building products for customers. Now, when you look at smart factories, there's tons of different areas that they wanted to improve upon, everywhere from the actual manufacturing of a product to their maintenance systems, surveillance systems, ERP systems, you name it. They've spent a lot of time adopting different technologies, different systems to make their operations more efficient. Some of the pain points we found from working with them that they saw was with public cloud availability. A lot of these factories are out in India, China, Taiwan, places that don't have as much internet connectivity, but a need for many different types of on-premise things, connected things. As they continued to adopt more and more different systems, they found that integration between the systems was very challenging, that they would purchase one system for managing a conveyor belt and then another system that had dashboards and other types of information on their productivity or assets, and those weren't integrating very easily. As you get to some of the larger factory customers, they have multiple different locations, floors, areas where they needed data mobility that they weren't achieving from the existing solutions out there. So some of the stuff we built as a company was a platform that first and foremost was a way to integrate all types of disparate sensors and systems. We leveraged OpenHAVE. I know you guys are familiar with it based on Manik's presentation. And then we extended it to add the ability to collect data as well. So this was back in 2015. OpenHAVE bindings were primarily discovery and control of different sensors. We realized that data collection was going to be an important part of this. So we extended the binding, and this will all be contributed upstream to the open source community soon, a way for us to identify not only how to connect to it, how to turn it on and off, how to control different states of a IoT connected thing, but also what type of data it generates. How do we normalize that data and organize it into an object that can then be used by another application? So this was all part of the work we spent about a year doing. When we decided to deploy it to a factory, we decided to put a hub on premise, having it run our stack, connecting to all these different types of connected things. And using Ubuntu Snappy, different snaps, we allowed multiple applications to be running on premise. What we did was then we enabled them to connect to their external clouds, and then a factory owner, a factory staff member could then use his phone, his tablet, a web browser to connect to all the different applications. These are all types of analytics applications, asset tracking applications. They're all running in their own individual snap, and they're able to function independently on this hub. What ended up happening, though, and this was a huge challenge for us as we were building this IoT solution, was the explosion of data. As we started as we started adding the cameras and the RFIDs and the different types of robotic arms and all the different elements out there, we found that not only was the raw data adding up, these are HD videos, very large video files constantly streaming. As you start increasing the cameras, you're getting a lot of high output data streaming into it. As you're running different types of processing and analytics on the data, we were doing face tracking. There was a camera up front at the entrance to the factory that was identifying people as they came in. We were doing heat maps. We enabled all of this to be happening on the platform. As you started adding robotic arms, some of these different automated systems in a factory are generating gigabytes per hour, tens of gigabytes per hour. We found as we were doing, integrating the raw data from these sensors and doing the processing and the analytics on them, we were having to manage terabyte plus per minute. The amount of data being generated was just way too much for this one hub that we had deployed on premise to handle. Furthermore, as you started increasing the number of things, the number of connected devices, the correlations between them would start growing. So if you had the analytics for one floor, the analytics for second floor, those may be independent on their own, but if you start drawing correlations now between different floors in the factory, that was its own set of data, its own set of analytics that just kept causing the amount of data to keep going up and up and up. And it became a huge problem for us, something that our customers had not seen before. So much different disparate systems that were integrated and creating so much data in a single location. It was too much for the system we had designed to handle. So what we ended up doing was creating multiple hubs throughout the factory, still powered by Ubuntu Snaps, and then putting a rack on premise that would then connect between the apps running across these hubs. We had our own IP developed to let these work as a cluster across the factory, and then allow the clients, the smartphones and the tablets and the web browsers to connect to the rack, which would then focus on collecting the data from all the distributed data collection hubs. What we found was this was very effective. Once we deployed it on premise, that's when we started signing contracts with all these smart factories. And what we feel is going to be the future of IoT architectures, where you have different IoT sensors on premise. I forgot to mention the hubs we're deploying are going to be Samsung Arctic-based hubs, if you guys are familiar with Arctic or went to the talk earlier. All running OpenHAVE, Mosquito for MQTT to be able to discover them, all focused on taking the raw data from these individual sensors and just collecting them, making sure that you don't miss anything, running those types of open source packages close to the sensors, and then deploying the rack or some type of local server. We have Ka running on this, where it takes some of that structured data and then enables the initial set of analytics applications. Think maybe predictive maintenance. If you want to be making a decision right away based on some error detected by one sensor on the conveyor belt, that's where you want to be running it on premise on a more powerful machine. And then letting it go up to an edge data center or a centralized data center where all the further learning can happen on a much larger data set. So then you have data flow going upwards towards the data center and control flow being sent back based on the learning done, the rules that are being set on these systems. And so one of the key takeaways we found is we're not the only ones doing this new tiered approach. We're seeing this in the media industry. We're seeing this, some of the automotive companies that we've talked to that are leveraging our underlying data management platform are using this. What we would like to see is, or if you guys have any further questions, I'd love to address them. Over time, seeing how this essentially becomes one single pipe instead of separate entities where data sits here and then it transfers over a large distance to some other location. We want the whole system to be processing and continually massaging, structuring data all the way up to the data center at multiple levels. That's pretty much the presentation. I wanted to speed it up to save time, but happy to take any questions. It's a more high level than some of the other presentations, but that's also intentional. Thanks. Yeah.
So curated cluster data stories, about that story. So the idea is that
That's a very good question, and it does depend on the type of connected device. So if it's camera, we're focused more on the actual raw data from, oh yeah, just making sure, the raw data from the camera, the video data. When it comes to a robotic arm, especially on a gantry belt where it's up top and you have to be managing the different X, Y, Z types of coordinates, that control data is also equally as important as the raw data in that scenario.
That's interesting, because that control tape, so on the XY axis, there's a beginning and an end, and you're collecting all the stuff in between.
Yep.
So I'm gonna get involved a little bit of that. I tried to get rid of that 80 to 90% of that full motion stuff,
Right.
because it turned out it really wasn't interesting. And when I got to the point where I was forecasting, I could pick up that intermediate stuff because it had to happen anyway.
Yeah. We found also as well, a lot of data is stuff we can throw away. We just want to make sure we collect everything so we can make that decision.
Are you telling your clients dev null is their new friend?
Sorry, I didn't hear what you said.
You're telling your clients that dev null is their new friend?
Yeah.
All right, thanks again, Sam.
Thank you.